Alright guys, today we're going to look at how to graph when you are in vertex form. Okay, so everything we've done so far with parabolas has been in standard form where it's just y equals ax squared plus bx plus c. Now we're going to look at it in vertex form, which shockingly enough gives you the vertex pretty much just by inspection. Like you can just look at it and be like, boom, that's the vertex. Finding some of those other pieces will be a little bit different and in certain ways trickier, but we'll still be able to manage all those things too. Okay, it's just a different form, and depending on what you're looking for, it may be beneficial to have it in one form versus the other. In our next lesson, we'll look at converting back and forth, but for right now, let's assume that we have things in vertex form. Okay, vertex form is y equals a times x minus h quantity squared plus k. Alright, so there will be numbers in for A, H, and K. Okay, obviously X and Y stay because those are our variables. When you have it in this form, the vertex is HK. Okay, the key is be aware of where there's supposed to be minus signs and supposed to be plus signs. Okay, really just a very, very quick example. If we had y equals 2x plus 3 squared plus 1, our vertex would be negative 3, positive 1. Okay, because there's supposed to be a minus sign in parentheses. Since there's not, and there's a plus sign instead, that means we've got to switch the sign on that. K, on the other hand, the sign we're going to keep the same. There are two questions that I really want you to consider. Now, I'm not going to discuss the answers here, but you can discuss those in your groups tomorrow or the next day, whenever everybody in your group kind of has this done. Two questions. What does the A tell us? Okay, the A tells us something about the graph. What do you think it tells us? Okay, and two, the second question I want you to consider is, why does it make sense that HK is the vertex? How could you, looking at that vertex form, be like, oh yeah, duh, HK has to be the vertex because, well, why do you think that makes sense? How could you kind of prove it to yourself or prove it to someone else? Those are the two questions that I think if you can answer those, you'll start feeling really comfortable with vertex form and why it's so useful. Okay, so how to graph when it's in vertex form. First, you find the vertex. It's easy. We just showed you how to do that. It's going to be HK. Okay, I still think you should find the intercepts. Again, I mean, for most of these graphs, you don't really have to find the intercepts, but it just makes sense. A lot of times, when we begin to apply this to motion problems, those intercepts are going to be very meaningful points, so you probably want to be able to find those. And then you want to find some more points on either side of the vertex if it'll help you make it more accurate, and then you graph. Okay, so I'll walk you through this first one. So this first thing I'm going to do is find the vertex. That's easy. It's negative 2, negative 1. Done. Simple. Okay, now I need to find the x-intercepts and the y-intercepts. Let's start with the y-intercept because the y-intercept is still very easy. I'm going to do this in a different color so we can kind of keep my work straight here. Y-intercept. To do that, we are going to plug in 0 for x and find y. This is not as straightforward as it was last time, but you can still, I'm guessing most of you will be able to do the work in your head. Okay, when we plug in 0 there, we get 2 squared, which is 4. 4 minus 1 is 3. So our y-intercept is 0, 3. Our x-intercept is going to be a little bit harder this time, our x-intercept or intercepts. Okay, we need to plug in 0 for y, and we get 0 equals x plus 2 squared minus 1. You have a couple choices for solving this. Option 1, you could simply use the quadratic formula. Now, before you would do that, you would have to, and I don't suggest you write this down, you'd have to multiply x plus 2 times itself, and then combine like terms, oops, I don't need that squared there anymore, combine like terms with the 1. I don't recommend you do that. Okay, we actually know how to solve equations like this. This is very similar to what we did with completing the square. Okay, so we have a perfect square trinomial that's already factored. So I'm just going to add 1 to both sides. And then I'm going to take the square root of both sides, keeping in mind that when I take the square root of a variable squared, I need to use absolute values. And I know how to solve that. I get x plus 2 equals 1, x plus 2 equals negative 1, and from there I get x equals negative 1 and x equals negative 3. So I get 2 x-intercepts. I get negative 1, 0, and negative 3, 0. Okay? And again, I'm guessing most of you probably could have gotten to, once you got to right here, you probably wouldn't have had a whole heck of a lot of trouble solving that in your head. Well, negative 1 gives you 1 in the absolute value, negative 3 gives you negative 1 in the absolute value, and absolute value of both of those is 1. So now I'm just going to graph all of these things. Okay, so let me graph my x-intercepts first. There's one x-intercept. There's another x-intercept. Graph my vertex. Okay, it's right in the middle of both of them. That makes sense. Graph my y-intercept of 0, 3. Okay, and I should make a point on the other side. Now, I think in this case it probably would make sense to try doing one more point. So you know what, I'm going to quickly see what I get when I plug in x equals 1. I get 9 minus 1 or 8, so I know the point 1, 8 is on my graph. 1, 8 is right here, and there's also then going to be 1 on the other side. I can make quite the accurate parabola this time around. And there we go. That's graphing in vertex form, ladies and gentlemen. It's really not that bad, and actually finding, this is why we save this for last, because you know the solving method that we used here, here and here, to find our x-intercepts. Turns out that's not really that bad either, and you can avoid the quadratic formula altogether. So I'm going to have you attempt the next two. If you get stuck, you can feel free to just pause and watch. That's fine too, but try to do it on your own if you can, and then watch to the end and see if you did it right. Okay, you'll have a good idea if you did it right, because when you start plotting points, they should look like a parabola. If they don't, you probably did something wrong. Okay, so pause, try, and then come back. Okay, I'm assuming you've tried a little bit. Vertex for this one is 1, 4. The y-intercepts, I plug in 0 for x, and I get y equals negative 1/4, 0 minus 1 squared plus 4. The math here is a little bit harder to do in your head, so I may have to write out a quick step. Negative 1 squared is 1 times negative 1/4. And I get negative 1/4 plus 4, which is, you could either write just 3 3/4 or 15/4. Okay, so almost 4. All right, and then the x-intercepts, I'll do in blue, plugging in 0 for y. This one, the completing the square solve process, I don't know that we've exactly seen ones like this before, but hopefully you find it pretty intuitive. So I want to subtract 4 from both sides. Now, I don't want to square root both sides yet because I can't take the square root of either of those negatives, but I've got 2 negatives. What I'm going to do is, to get rid of that negative 1/4, I'm going to multiply both sides by negative 4. Okay, and that is going to get me, I'm going to come up here really quick, that's going to get me 16 equals x minus 1 squared. There, now I can do the part where I take the square root of both sides. So take the square root of both sides, and I get absolute value of x minus 1 equals 4. So I could probably just do this really quick in my head. I know that 5 minus 1 will get me my positive 4, and I know that negative 3 minus 1 will get me my negative 4. So my x-intercepts are 5, 0, and negative 3, 0. Okay? So I'm going to plot these points, and then I'm going to see if I need any others to help me out. Okay, so I've got the point 1, 4. That's right here, plotted in red. Okay, my y-intercept is almost at 4. So that one is really just right here. Okay, that point is almost not really very useful. Okay, I mean, I kind of want to make sure that I go through it, but really it's not super useful in this one because it's so close to the vertex. Then my x-intercepts, these will be really helpful though, are 5, 0, and negative 3, 0. Ideally, I think I would want one more, so I don't know, this actually might be about good. What I can tell right here is, oh, there's another point right about here, that this parabola opens really, really very wide. Okay, opens much, much wider than the other ones. There we go. And that should be a pretty accurate graph of this parabola. All right, let's try the last one. The last one's got a little bit of a trick to it. If you did it already, you've probably figured out the trick, or you're extremely confused, one or the other. Okay, quickly, vertex. I'll do vertex in green this time. Vertex is 2, negative 4. Y-intercept, be a little bit easier this time. Plug in 0 for x. And then, come on, we can do that math in our head. Negative 2 squared, we do that first, is 4. 4 times negative 3 is negative 12. And negative 12 minus 4 is negative 16. So I have a y-intercept of 0, negative 16. We're going to have a hard time plotting that one. X-intercepts, I'll do it in red this time. And here's where the problem's going to occur. If you did this problem already, you have probably figured it out. I'm going to add 4 to both sides. And same thing as the last one, I need to divide by that negative 3, so I get negative 4 thirds equals x minus 2 squared. If I take the square root of both sides, I can't take the square root of that side. I don't have any x-intercepts. So really, all I have right now is 2, negative 4 as my vertex, and that's really it. Okay, and unfortunately my other y-intercept is way too far down for it to be really useful. Since I have no x-intercepts, I know this thing opens down. So what I'm going to do is I'm going to quickly plug in x equals 3. Okay, to give myself one more point, and then that'll be able to give me a second one because I can use the axis of symmetry to find another. Okay, so 3 minus 2 is 1, 1 squared is 1. I get negative 3 minus 4 is negative 7. So I get the point 3, negative 7. That's right here. There's got to be another point on the other side. Now, based on the graph that I gave you, this is unfortunately the most accurate one you could really make. Those are the only points that really fit nicely on your graph. And that's okay. That's certainly going to happen sometimes. Okay, so hopefully this helped you out with working in vertex form. Next lesson we're going to work on kind of converting back and forth between the two forms.